Alright, today we're going to do lesson 54, reducing fractions, and also we're going to divide fractions. We've already done a little bit about dividing fractions, but we're going to do a little bit more. Now for example 1. This is a little bit of review. You guys know that anything over itself, so say 5/5, anything over itself is equal to 1. Okay? Now if I had 5/5, let's say 5 times 5 over 5 times 2, since this 5/5 is part of the fraction, you can basically say this is 5/5 times 5/2. Okay? And 5 over 5 is the same as 1. So this is really 1 times 5/2, which equals 5/2. And of course you can change that to a mixed number if you would like. The way instead of working it out like this, the way I like doing it is just canceling out the two 5s. So just know that anytime you have a number and a number in the numerator and denominator, and that's the same number, you can cross them out because it's basically 1, and all you'll have left is 5/2. 5/2. Alright, so hopefully that makes sense. Let's do a couple more practice problems. Alright, here's another problem. 2 times 2 times 2 times 5 over 2 times 2 times 3 times 5. So you just look for numbers that are paired up. So this 2 and the pair has to be the same number. This 2 and this 2 are paired up, so they cancel out, becomes a 1. Same with these two, they cancel out, becomes a 1. Then you have a 2 and a 3, nothing happens, and the 5s cancel out. So all you have left is a 2 and a 3, a 2 in the numerator and a 3 in the denominator. So the answer to this problem is 2/3. Very easy. You can also find a pair of numbers to cross out even if those numbers aren't right above each other. In a situation like this, it's easy to see that 2 and 2 are a pair because they're right next to each other. But in this situation, the 7 and 7 can also cancel out. Just because they're not right on top of each other doesn't mean they can't cancel out. So we're going to cancel those two out, and then the 3 and the 3. So all we have left is a 2 times a 5, which would be a 10. And then on bottom, all we have left is a 10. 2 times 5 is 10. So 10 over 10 cancels out. So all we have left is 1. So all that is equal to 1. Kind of a fun problem. Alright, example number 4. How many 1/2s are in 3/4? Well, let's use numbers that we're more accustomed to using. So let's say how many 2s are in 10. Say this is a 2 and this is a 10. In order to figure that out, you would say 10 divided by 2. So 10 divided by 2 would equal 5. So there are 5 2s in 10. So we're going to do the same thing with this. How many 1/2s are in 3/4? So we're going to take we're going to take 3/4. We're going to divide that by 1/2. That'll tell you how many halves are in 3/4. So let's go ahead and do that. Okay, you guys remember the keep, change, flip little algorithm. It's basically multiplied by the reciprocal. We're going to do the same thing for this. We're going to rewrite this problem directly below it. And the first fraction right there, we're going to keep k. That's what the k stands for. So we're going to keep it the same, 3/4. And the next one, we're going to change. So we're going to change division to multiplication. And the last one, we're going to flip. And that is basically like saying multiply by the reciprocal. And so in a reciprocal, which is flipped, so to speak, everything on bottom is now going to be on top. Everything on top is now going to be on bottom. So switch to numerator, denominator, basically. Now you can multiply straight across. 3 times 2 is 6. 4 times 1 is 4. Okay? Then you can reduce, if you divide top and bottom by the same thing. Divide them both by 2. This will be 3 halves. which is the same as 1 1/2. So there's one answer. Let's do another problem. Alright, this one is going to be number 5. And instead of saying how many halves are in 3/4, let's ask ourselves the question, how many 3/4 are in 1/2? In order to do that, we're just going to switch these around. Okay? Instead of having 3/4 divided by 1/2, we're going to have, you guessed it, 1/2 divided by 3/4. Okay, rewrite the division problem right below. So we're going to keep k, keep the first fraction, change the division to a multiplication, and then flip. We're going to flip 3/4. Instead of 3/4, we're going to get 4/3. Alright, then you multiply straight across. 1 times 4 is 4, 2 times 3 is 6, and this is going to reduce to 2/3. Alright, so hopefully this makes sense. If you notice, this is the reciprocal of the previous problem we had, which was 3/2. Now it's 2/3. And that's pretty much all I got for today's lesson. I'll go over a couple of homework problems. Alright, number 4 from your homework says Mary Hani, it was 59 3/4 of an inch tall when she turned 11, and 61 1/4 of an inch tall when she turned 12. How many inches did Mary Hannah grow during the year? So this is a difference problem. She's different when she's 12 than she was when she was 11. So in order to find difference, you are subtracting. So we're going to take 61 1/4 of an inch, and from that we are going to subtract 59 3/4. That way we can find the difference between these two heights. So how much did she grow? 1 minus 3, you can't take 3 away from 1, so you got to borrow from the 61. That's going to be turned into 60. So we're going to add in 4/4 right there. 4 plus 1 is 5. So you don't need that anymore. Okay, now you can subtract. 5 minus 3 is going to be 2. The 4 is the same. Okay, 60 minus 59 is 1. We know that 2/4 reduces to 1/2, so the answer for here is 1 1/2. That is your answer. Alright, this problem involves a little bit of order of operations. So when you're doing your operations, it goes, please excuse my dear Aunt Sally. Please stands for parentheses, so that means anything inside the parentheses you're going to evaluate first. So this would be 100 minus 1, which would be 99. Once you evaluate the parentheses, bring everything down. Now we're going to have 1,000. We're going to subtract 99. And we know 1,000 minus 100 would be 900, but we're not quite subtracting 100. We're only subtracting 99. So what's instead of 900, it's going to be 901. Okay? Alright, we want to find out what number is halfway in between 37 and 143. So this is basically an algebra problem. What do you have to do when you're doing algebra? You have to add up and divide. So I'm going to take 143 plus 37. Okay, 7 plus 3 is 10, carry your 1. It's going to be 8, 1. 180. So you're going to take 180. Divide that by 2. The reason why I picked 2 is because there's 2 numbers. You divide by the number of numbers. 2 will go into 18 9 times. 9 times 2 is 18. Subtract 0, bring down your 0. 2 will go into the 0 0 times, and no remainder. So the answer is going to be 90. 90 is halfway in between 37 and 143. Alright. Number 8 can be kind of confusing, but you have to know the difference between $1 and a cent. A cent is 1/100th of a dollar. Alright, So I'm going to change, since we have dollars and cents, I'm going to change them to both of these to dollars because it'll be easier to work with. So I'm going to change this to $3 with 2 zeros. I'm going to subtract in, and that's going to be 24 cents. Alright, so I'm going to subtract $3 from both sides of the equation. All we're going to have left on this side, because that's going to cancel, all we're going to have left on this side is n equals, now this is going to be $2.76. Okay, actually it's going to be negative $2.76. Alrighty. And then since this is negative and this is negative, I can make them both positive, so my answer is going to be n equals $2.76. Don't forget your label.